Yes, colleagues, I am most welcome to this lesson. I am your friend, Gava Stewart, and today I would like us to look at something brief, and we are going to look at what we call magnetic effect. Magnetic effect on electric current. An electric current. So in this that we are going to discuss, we have two broad words or branches: magnetism and electricity. So in your previous studies of physics, I believe you must have looked at magnetism, and you must have been introduced to electricity. And during your study of magnets or magnetism, you should have been told that magnets have got properties. If this is our magnet, you should have been told that magnets have got poles, in this case, the North Pole and the South Pole. And you must have been told that around a magnet, there is always a magnetic field. Now, this magnetic field is represented by magnetic field lines, and these magnetic field lines are said to originate from the North Pole and towards the South Pole. So there is this that they originate, that they originate from the North Pole and towards the South Pole. Must have studied that in physics at earlier stages. Now, the other thing that we are supposed to explore here is that when we have got a current carrying conductor and a conductor that is carrying current, this current carrying conductor always has a magnetic field around it. So very important to note that a current carrying conductor, has magnetic field around it. This is something to note. Very important to note. Now, unlike for a bar magnet or a horseshoe magnet or any magnet, whereby we say the direction of the magnetic field can be predicted if we know the polarity of the magnet. But in this case, if we have a current carrying conductor, it may not be very easy for us to determine the direction of the magnetic field unless we use these two rules. So the first rule that we use is the right hand grip rule. So we use the right hand. One of the rules to determine the direction of the magnetic flux or the magnetic field is the right hand grip rule. So in this case, how do we use it? We imagine, or you imagine yourself gripping a, a current carrying conductor, gripping it with your right hand. So if this is your right hand, yes, this is your right hand, you imagine yourself gripping this conductor with your right hand, and then with the thumb, this thumb, pointing in the direction of flow of the current. So if this is my right hand, and this is the thumb, if current is flowing upwards, the thumb points in the direction of the flow of current. If the current is flowing in the other side, this direction, the thumb points in the direction of the current flow. And then the flow of the other fingers shows you the direction of the magnetic field. So my fingers are flowing in this direction. So it means this is how the magnetic field will be moving around this current carrying conductor. So if we have this, we've said if this is our conductor, we assume that it is carrying current upwards. Let's use the next page. We have this as our conductor carrying current upwards. So there will be magnetic fields around, there will be a magnetic field around this wire or this conductor. But this magnetic field is always in terms of concentric circles. These circles seem to be sharing a center, and they move around this conductor. So if imagine yourself gripping this conductor and your thumb pointing in the direction of the flow of current, I believe that your fingers are going to flow in this direction. You can hold your pen or anything around you, and you take this that pen or something to be conductor carrying current upwards. So you'll see that the direction of the magnetic field will be in that direction. So this is if the current is flowing upwards. So if this is for current flowing upwards. So what if the current is flowing downwards? Current flowing downwards. So in this case, you also imagine yourself gripping this with your right hand, and of course the thumb pointing in the direction of the flow of current. So in this case, this is how I guess your fingers, the other fingers would be moving. So that's, you can try to draw other diagrams for current which is flowing to the left, to the right, etc. Now, we want to look at a case whereby we have two conductors that are close to each other. One carrying current, conductors carrying current in opposite directions, conductors carrying current in opposite directions, but when they are close to one another. So let us assume a practical example we can use here is a coil, whereby we have, like, in one of the sides, current is moving up, and in the another side, current is moving downwards. So around this side of the coil, if we look at this will be how the field lines would be. Then continuing to draw more fields. So that they are not perfectly circular. They are not perfectly circular. Then this other side here, the pattern will almost be like that one. The pattern will almost be like this. So this is how the field lines would be for two conductors that are carrying current in opposite direction, and these conductors are close to one another. Then what if these conductors are carrying current in the same direction? Let's have this carrying current upwards, and then this one also, this other one also carrying current upwards. So if we can draw, sorry about that. This time let me rub it. Let me rub this. Clean that also. So if we have these field lines, so upwards, this side will be down, and this side up, the arrows, and here the direction of the arrows will be the same, downwards, here upwards. Further drawing of these field lines, you'll find that this is how they will behave. So you can also go on and try where both say carrying current downwards. You have two carrying current downwards. You can draw those that are carrying current into the computer, outside your computer or the phone, depending on the gadget you're using. So what we have learned today is that any current carrying conductor has got a magnetic field around it. Then next time we shall look at the magnetic field line or the magnetic field pattern around a solenoid. Thank you very much for watching, and I wish you a nice time, and I'm very grateful.